So today we are going to have an introduction to FME. We have Matt Lennox, GIS Administrator for the City of Oshkosh. He's been that administrator since July of 2019. He has over 10 years experience in the geospatial industry, working in both the public and private sector. He learned GIS in school at the University of Iowa and continued his education at Portland State University and Portland Community College. He learned FME in his previous job working for an electric utility company in Portland, Oregon. He has brought his FME experience to the city of Oshkosh. Outside of work, he loves to spend time with his family and is passionate about spending time outdoors. And Matt, if you want to take it away.
Yeah. So thanks for the introduction. As I said, I'm Matt Lennox. I'm currently the GIS Administrator here at the City of Oshkosh. Today, I'm going to talk about FME and then how we use FME in our Child Abduction Response Team, or otherwise known as CART. So I'm just going to do a brief outline here. So I'm going to do an intro to FME and just, what is it? I'm going to kind of assume that that most other people don't know what it is or haven't used it, or maybe have heard of it but haven't really seen it. So I'm going to attempt to do a live demo showing some of its capabilities, and then I'm going to get into how we use it for our Child Abduction Response Team, and with that also show a live demo of how we're using it. So 2 live demos today. So here's some slides about an introduction to the Fme platform. And these I did get from Safe Software, who is the maker of Fme. So some of it sounds a little like it was developed by a marketing department. That's because it was, but it's still nonetheless a good introduction, I think. So Fme stands for Feature Manipulation Engine. It's made by Safe Software, a company out of Vancouver, BC. So Fme enables you to connect data between applications and transform your data in limitless ways using a visual interface. Automation frees you from the burden of manual tasks. So you can connect your data sources and integrate them in with over 450 plus different systems, using transformers that are custom built by Safe Software. And then you can automate your workflows either using Fme Server, which is a product by them, or you can also use things like Task Scheduler in Windows. The most easiest way I like to think about it is Fme is like model builder in ArcGIS, something like that. That's kind of the most easiest way to think about it. So connecting your data sources. So connecting data from multiple sources enables you to power business decisions with all of the information that's available. Fme supports geospatial data, structured data, and unstructured data, linked data, and time series and more. You can extend Fme with custom connectors through REST, R, Python, and other technologies. So transforming your data. Fme enables you to transform your data for any purpose. The library of transformers enables you to integrate your data to suit the best fit for purpose applications, formats, and standards you've chosen. This increases the value of data by making it more usable when, where, and how it's needed. So I'll show this. I'm going to do a live demo, but these are the transformers over here that you can see on the screen. This would be like a reader here reading in data and transforming it and then writing it out to different formats. You can easily expand your workflows to include new data sources as they become available. And then automating your workflows. So automation saves you time and ensures the data arrives on time. With Fme, you can create your automation for transformation and event-based workflows in a GUI. Set up business rules that trigger workflows to run on schedules and in response to events. You can also automate workflows to send notifications via SMS, email, or various web protocols. For example, you can set up a data upload service that provides validation and a detailed pass-fail report, which accepts past data, or you can securely provide data however it's needed for self-serve access. So this over here is what FME server looks like. Probably hide that. This is what FME server looks like over here. So it's a little different than FME desktop, but you author scripts in FME desktop, and then you can upload them to FME server for automation purposes. So here's a kind of rundown of the FME software suite. So you have FME desktop, like I was just saying, and here, this is where you build and run data workflows. You have FME server, where you can upload those scripts that you author in desktop to do the automation. You have FME cloud, which is FME server, but hosted by them. And then they also have some mobile products as well too. And you can get a free trial of any of these at safe.com. You so choose. So again, they have a self-hosted option where you can install FME directly on your own hardware. They have it in the cloud, and they also have a marketplace, which I'm not too familiar with, but I think it's just kind of a pay-as-you-go kind of system where you can just, they have kind of pre-built, spun up server instances in the cloud, and then you can just kind of use them and pay as you go for what you need. So I'm going to attempt to do a live demo. The goal of this demo is I have some permits from the city's permitting software that are for burn permits specifically. And it's just a table with no geometry. So I'm going to merge those permits in with our parcel data. I'm going to create a feature service on Arcgis Online that then can be used in a dashboard, or can really be used in anything once it's up there. So as I was saying, yep, this is just a blank canvas right here. So this is FME desktop, just a blank canvas here. So you have your readers and writers up here. So we can read in data from many different formats, and those can mostly all be seen here. I won't go through all of them, obviously, because there's many, but these are all the different types of data that you can read in. So in my case, I have some data in a FileGeo database, and that is stored just on my C drive here for presentation purposes. So I'm going to choose that FileGeo database. I'm going to open up the parameters, and I'm going to read in the data that's in that FileGeo database. So I have my burn permit table, and I have my tax parcels. So I'm going to go ahead and OK. And what it's doing now is it's reading in that data, and it did. So now I have in the canvas, I have my tax parcels and my burn permit tables. So within FME, you can run the whole entire workspace, or you can read in data individually. So I'm just going to go ahead and individually, I'm going to read in my tax parcel data. And sorry, again, this is probably kind of small, but after this reads in, you can see that we have the geometry of our tax parcels over here. And then we have our table here that shows all of the attributes that are in that table. So this is called the visual preview window down here. And it used to be a whole separate program, but then they built it into FME desktop, which is kind of nice. So you don't have to go out to a different program. So those are our tax parcels. Here's our burn permit table. And so we're going to read this in. And there's 914. So there's no geometry. This is just a table in a FileGeo database, but you can see the table here and all the attributes and everything here. So you'll notice that we have parcel ID here, and in the tax parcel data, obviously we have our parcel ID as well too. So one of the goals of this is to merge our tax parcels in with our burn permit table. And to do that, we're going to use what's called a feature merger transformer. which is basically just a joiner, but the terminology is a little funny because you have requester and supplier. Requester basically just means that these features are requesting something, and this what they're requesting is what's from the supplier, which is going to supply them. And they're going to do that on parcel ID from the tax parcels, and then parcel ID from the burn table. So as I was saying, with the feature caching, you can also do that in the transformer as well too. So we can go ahead and run that. So we got an error, which I was expecting, but we have one rejected feature, and that's been rejected because there's an extra reference feature. And all that really means is that the feature merger is a one-to-one basically. It's not a one. You can do one-to-many, and I'll show you how to do that in a little bit here. But inherently, it's just a one-to-one joiner. So what we can do is we can add these into an inspector. So all these rejected features will kind of go into this container here. So we can go ahead and run this. And so we can see that we used 886 records from the burn permit table. There were 26 rejected, and then there was 2 unused suppliers. So what that means is there was 2 records in the burn permit table that didn't have a matching parcel ID. So we're going to deal with those in a second here. But part of the goal of this is on our final product, we don't want polygons, we want points. So we're going to add in the center point replacer. And what this is going to do, as the name implies, it's going to replace it with a center point. There's only a couple parameters, and one is center point of bounding box. We're going to go ahead and use that. And we're going to go ahead and run this. And now we can see that we have, I know it's, oops, no, it's small, but we have points. We have our parcels. So we have 886 parcels that have a burn permit. So these are all the parcels with a burn permit. And you can see now that we have points instead of polygons. So from there, we want to start eliminating all these attributes, because we have all these attributes in here, and we don't need any of those. We don't need all of those. We need some of those, but not all of them. So to do that, we're going to add in an attribute, if I can spell, attribute manager. And the attribute manager does like what it says, it manages the attributes. So in here, we can start eliminating things we don't need. So we can, we don't need that parcel ID. We need this one. We need owner name and site address, but we don't need any of these. So we can start going through and just eliminating attributes. We'll keep those 2 in there. These are pretty much all the parcel IDs. We don't need any of those. We can eliminate those. We need permit number. We don't need that parcel ID. We don't need that address. We need description, permit date, sure. And we need template. But the rest of these we can all blow away. So now, after we hit OK on that, you can see these are all the attributes we're left with. And we can go ahead and run this. And these are the attributes now that we're left with, and we still have our points over here. So, so we basically eliminated all these attributes, and just now we're just working with these ones here. So now I like to add in another attribute manager, put that up, and now we can go in here and we can start changing like parcel ID, owner name 1, owner name 2, site address So you get the idea. So we can go in there and we can change attribute names and do other stuff in there too. And now we have parcel ID owner name. So it looks a little bit cleaner. We can also notice like we don't condo name and description. Those don't have any data in them. So we can just go ahead and remove those from here. And if we run it again, now we're left with just this nice table here. So again, so we had our burn permit table. We joined them in with our tax parcels. We replaced the geometry with a point. We eliminated and renamed attributes. So at this point, we're ready to go ahead and write out to Arcgis Online. So we can add in Arcgis Online as the format. We can choose our connection and we can name this like burn permits test 1 or something. And we can hit OK. It's layered definition. This is asking what are the attributes that we want? And we're going to say manual, because I'm just going to add those in manually. So geometry, we know we have points. And our layer name, again, we can just say burn permit test. We can go ahead and hit OK. So now we have a container in our canvas that is pointing to this, what's going to be a newly referenced feature service on Arcgis Online. So, but we don't have any attributes in here. You can see these are all yellow here. That's saying that it's not finding any matching attributes in the writer. So we can right click on here and we can say copy attributes from transformer, attribute manager 2. So now these are green. Now these are all green, so we can easily add in our attributes from there. And as soon as we run this, this is going to connect into Arcgis Online. It's going to write out features. And let me get this pulled up here. So in my Arcgis Online account, now we can see we got burn permits test 1. And we can open it up and we can see in the data that we have the 886 records. So, so I'd like to go back and just show how we can then deal with these 26 rejected ones and these 2 unused suppliers. So I mentioned before, so the feature merger is basically a one-to-one. You can make it a one-to-many through lists. And lists are kind of an abstract kind of concept that frankly took me a while to fully understand. But I think about them as it kind of zips up duplicate records and sort of holds them in memory within the workspace. So so if I create a list on these and I run this, these 26 here should go away into the rejected that we had. So now it says we're using 912 suppliers, but we still have these 2 unused suppliers, but it says we use 912 of them, but out of the merged ones, there's still only 886. So to get the values out of the list that we just created, we're gonna add in a list exploder. And we choose our list. Move this over a little bit. Go ahead and run this. And now we got the 912 here. And might help. So when you explode the list, it adds in a field here, the element index over here. So if we scroll down, we should be able to find, there we go. So when you have duplicate values like that being held in a list, and then you explode it, it adds in this element index of the first one's going to be 0, and then if you have how many you have, it'll just number them sequentially. You can see that we have the 3 parcel IDs there, and without making a list and exploding it, you would just see that first one there. So now we got the 912. And so basically, if we look at the geometry of those ones, oh, I should have, you're just going to have duplicate coincident like stacked polygons now for those ones. Let's see here. So go here, say zoom to selected. So we can select these and you can see we got 3 polygons right there, which is fine for demonstration purposes. Now we can go ahead and we can just run those through the center point replacer. And it's going to do the same thing. So if we were to go back to those same 3 that we found, and we zoom to them. So we should have 3 basically coincident points stacked on top of each other, which again, for this purpose is fine. So we can run that back through here. And so when we get to the writer, we want to add those new features in. So we want to truncate the writer first. So it's going to truncate everything in there. And then it's going to, when I run this, it's going to write out all those 912 records to Arcgis Online. And so that usually takes a little bit of time because it has to actually go in, truncate the feature service, and then rewrite everything. So if we go back into our Arcgis Online, so now we can see we got the 912 here. And if we were to zoom into those points that I are on the map before, you would see there'd be 3 points stacked on top of each other. So these last 2 over here, these unused suppliers. So there's no parcel ID in the burn permit to find a match in our parcel data. So for those, we have an address for those ones, so we can geocode them. So I can add in a geocoder, and I like to use OpenStreetMaps, and then I can add in the address, and then I can help it out a little bit by saying Wisconsin, because I know that's where they are. And I can go ahead and hit OK. I can run those through the geocoder. And we should have 2 points here. And so now again, we can go ahead and just connect these in. We don't need to replace them with a center point because they're already a point. And we can go ahead and just write out all that data back out into Arcgis Online. So now you can see instead of 912, we have 914. So if we go back into Arcgis Online, do a little refresh, now we got the 914. And these are the 2 here that were geocoded because they don't have any parcel information there. So you can see how, this is just one example of how you can take data, read it in, transform it, manipulate it, and then write it back out. And if you scheduled that, you could schedule that to run every day, every night, every hour, or you could set up a trigger to run in your permitting system. When a new permit gets added, it would automatically trigger that script. And then, so this was based on a semi-real world example of a dashboard that I put together for the fire department to show, where the burn permits are within the city. So that gives you just an idea of what FME is and how it can be used. So you're probably thinking, well, what does that have to do with finding missing children? So I'm going to go back in here and talk about that. So FME, Safe Software, they do what's called a world tour. And last year it was virtual. And they asked me if I wanted to present on this topic. And so these are the slides from that I'm going to use to re-show you here. So to give you a background on, so the Child Abduction Response Team, otherwise known as CART, it's a formalized process that you have to go through in order to become a recognized CART team. And so Winnebago County and collaborating with City of Oshkosh and other municipalities within Winnebago County, we became, I think it was the 21st or maybe the 22nd CART team in the nation last year. And so here at the city of Oshkosh, a systems analyst there developed a program called Leads Tracker. And I'm going to show this, a live demo of this in a little bit. But what Leads Tracker does is kind of like what the name implies. It tracks leads. So if there's a missing child, and maybe the public knows about that, or maybe they don't, but when they would call in that, let's say they find like a missing backpack or something suspicious, when they call that information into the dispatcher then has a way to organize leads and being able to relay that information to the whole team. And so we do that within what's called Leads Tracker. So Leads Tracker, it doesn't have a strong mapping component to it. It's got, I'll show it in a little bit, but it just has some real basic stuff. So part of the objective here was to integrate Leads Tracker in with Arcgis Online to enable the real-time mapping and decision-making in Leads Tracker to give incident command leaders kind of a full picture of what's going on. And so in order to do that, we had to automate the process of mapping the spatial data, when an incident is created, leads, and then any assets associated with that incident. And this enables the CART team to quickly deploy targeted search and rescue resources efficiently. So part of the challenges here was to replace our old manual process of mapping and compiling incoming leads. And so during like a training incident, the GIS group was getting overwhelmed by not only trying to map the leads in real time manually up on Arcgis Online and then onto a dashboard, but we were also getting hit with like special map requests or people coming up and asking us to troubleshoot IT related issues or whatever it may be. So the mapping, it was really hard to always keep up on it during one of our training exercises. So so what we want to do, like I was saying, is to produce and deliver a real-time visual map back to the command center. And so to be able to do that, so we took our Leads Tracker, which basically is behind Leads Tracker is an SQL database, is a SQL database. So all that information that goes into Leads Tracker gets stored in the SQL database, and FME is able to read that SQL database and then automate the process of uploading Arcgis Online and subsequently a dashboard via FME server through webhooks, which I'll talk about in a little bit, to update the map in Arcgis Online. So I'll show this, like I said, but this is just what an example of what Leads Tracker would look like. So when a child would go missing, an incident in Leads Tracker would be created, and they would do that in the incident tab in Leads Tracker. There's a latitude and longitude dropper there that they can drop on that exact location where a child was last seen. And then they can go ahead and enter that incident into Leads Tracker. In the background, in the SQL database, a webhook I created on FME's server was inserted into the SQL code that would run this script here. So this script would look at that incident, it would create a point from it, it would buffer it by 0.25 miles, because there's different statistics indicating that if you know the last place a child was seen before they were taken, and you're able to, get to there within a certain amount of time, they're most likely within a quarter mile of that location. So as soon as that incident would go into Leads Tracker, it would be mapped out with this script and then buffered by 0.25 miles. And then it would be put onto the map, which I'll show. So here's a real quick example of what the webhook would look like. So I know SQL, but I'm not a SQL expert by any means, but the system analyst here who created Leads Tracker does. So it was actually surprisingly easy to create a webhook on FME's server. And so that webhook has parameters in it. And so like the incident ID here, so in the webhook, it's equal to null, but in the SQL code, he's able to then populate the value of that parameter with data from SQL. So basically, if there's an incident, that incident ID gets put into the webhook, and then that incident ID gets put into FME desktop on FME server, and then it knows which incident to write out from the SQL database. And so FME server, one of its many things that it's good at is doing jobs very efficiently. So a lot of the jobs that run within seconds for this specific project. A lot of the times you have a little bit of lag on the Arcgis Online side when a lead or an asset or something gets written out. Arcgis Online has to do some refreshing and takes a little time for it to come in on that side of things. But most of the time, FME server does a really good job of processing. So you can see here, this is what it looks different now, but this is what it used to look like on Arcgis Online. You have a place last seen, which is this red asterisk, and then this 0.25 mile buffer that's around that point. So that would be an example of what the place last seen would look like. And so some of the results on this are that so automatically mapping out lat long marker locations from SQL database into Arcgis Online in seconds. Having Leads Tracker, having the map be automatically updated from Leads Tracker gives our incident command leads a clear picture of what information they're getting from the field, and allows them to make better decisions in real time based on what they're seeing. And so, overall, it's been a huge success doing it this way, and through some of our training exercises, the feedback we've gotten has been quite good. So again, some of the benefits are being able to fully utilize a complete and real-time mapping environment. Spatial data is mapped more accurately and efficiently through lat long and geocoders than manually mapping. So previously, we'd be looking at Leads Tracker, a lead would come in, we would look at the address, or maybe manually copy and paste the lat long and put that into Arcgis Online, and then try to map the point. And then so it just, with all the other requests and things that were coming in, it was hard to keep up on it. And in these situations, things happen so quickly and change so fast that, again, it was just hard to just keep up on it. So I'll show what it looks like, but you can see, like, so here would be like place last seen, the 0.25 mile buffer. The orange triangles are where leads would come in. There's some other like assets on there, like roadblocks, medical stations, etc. So I'm going to hop back out of this PowerPoint again, and I'm going to open up my browser here, try to get around that. And so here is, here's just a test version of Leads Tracker. So this is just like our sandbox that we can use to test with. Let me log back in here. This is FME server. And then this is the dashboard that that we created to show into the command center. So I'll go into leads tracker and I'm going to create a new instance. You can see I got a ton in here, but we're going to go ahead and add one more in. So we'll call this WLA test 2. So we can go in here and we can drop, we'll use the EAA grounds for ease of use. So what I just did there is, that would be an example of the incident command lead, or somebody would go in and say, okay, this is the place last seen. So they drop that down there and they hit add. As soon as they hit add, the webhook gets triggered on FME server, and you can see that there's a script here running now, this place last seen script. And it's completed. So you can see that the place last seen script has been completed. If we go into the dashboard, we should be able to see, oh, I literally dropped one on top of one that was already in there, but that's okay. So you can see that, so this was the one that I just entered, WL test 2. So there it writes out the 0.25 mile buffer, the place last seen. It adds it to this incident description over here as well too. So if you have multiple incidences at once, you can use that to zoom to and from. So if we go back to leads tracker, we can go into our leads tab, and from here, this would be where the dispatchers would then be entering in leads as they would be coming in. Sorry, I just had to take a quick sip of water. So if we go ahead and hit add new, we can add in an address if we know an address. I'm not going to do that, but if we did, it would run it through a geocoder in FME, kind of like how I showed with the burn permits. But just for ease of use, I'm just going to stick with the lat long dropper. So, so I can go down and I can say, okay, there was a lead entered in, or there was a, let's say a backpack or something, and it was last seen there. So we go ahead and close that and we hit save. Again, as soon as we hit save, job is triggered on FME server that runs a lead updater script, and then it writes it out to the dashboard. We can go in though and we can enter in more information like into those comments like backpack, found, whatever it may be. We hit save again. As soon as we hit save, another job ran, but that one ran in 3 seconds, so it ran really fast. And then we can say like urgency is immediate, and we can assign it to the Canvas team. And as soon as we hit save there again, another job here is ran on FME server. And again, that's all through webhooks. So we can see that those jobs have all ran. We go into our FME server, or into our dashboard, sorry. You can see here, that was the lead that we just entered. Backpack found, and it also is added to this list over here too as well. So the urgency was immediate, backpack found, the date time, and then the status gets put onto the dashboard. So if for some reason something in this, that's lead number 58. So if we're, if we go back into it and we need to change something in there, we can go back into it and we can, let's say it was like, oh, it was actually over here. So we go ahead and close and we save. And we go into FME server. Obviously, when this happens, I'm not going into FME server every time, but I'm just kind of showing it. So I moved it over there. And then if some of the status here changes to, or if we want to change that status to it's actually closed. So we're going to hit save. We'll just go back to the dashboard. And it takes a little bit for the refresh to happen, but this status here should change to closed. So there we go. Now it changed to closed. So we know that that lead is now closed out. And we can also, in the dashboard, we can also filter, like see all of the closed ones, just see the open ones, the follow-up pending, you know, or any number of combinations of all those, or we're going to say see all of them. We can filter on lead urgency. So if we just want to see the immediate ones or the priority ones, we can do that. And then if an incident goes on for a long time, we can enter in, you know, a custom date range, and then it filters out the leads just based on that as well too. So I'll go ahead and X out of those so we can get back to showing all the leads. So again, in leads tracker, so we can enter in leads, the incident or the place last seen, and then assets. So if we have like a, let's say a roadblock, and again, we can go to our Google Maps dropper. We can say there's a roadblock there. We hit close, we add it, and we can see on FME server that the asset script ran, and then we go back in, and there it pops up there. There's the roadblock there, and we also have a list of assets over here as well too, where they pop in over here as well too. I didn't add a description into that. This is one I entered in earlier, so yeah. But you can zoom to the different roadblocks or whatever assets you have in the field are out there. And if we go back into leads tracker, just show you again real quick, we could enter in like medical staging. Go back down here, we'll drop there. Yeah, medical staging, WLA. Add. And then if we go back into the dashboard, so during a real incident or a training exercise, this dashboard would be up on into the command center. There's the medical station there. And then there would be multiple people entering in leads and assets and things in the leads tracker. So leads tracker is sort of thought of as the master sort of copy, and then everything through FME and the webbooks is just written back up into the dashboard. It reflects everything that's going on in leads tracker here. And so same thing with the assets. You can move an asset or you can change any of the description, and then a job would run on FME server, and then, you know, that would be reflected out here onto the dashboard as well too. So, so that's pretty much it as far as the live demo goes. Showing leads tracker, FME server, and the dashboard. And I don't have too much in here. Just have one last slide that says thank you, and I'm happy to take any questions. That's my personal email address there. It's just my name, mattlennox@gmail.com. Tomorrow is actually my last day here at the city of Oshkosh. I took another job with a GIS consulting firm, Critigen. But if you'd like to chat or have any other questions besides today that you'd like to talk about FME or anything else, please feel free to email me at my personal email address. So happy to take any questions if there are any. Yep.
Yeah, there's a couple questions in the chat. How long did it take you to feel comfortable using the system? There are terminologies and tasks happening which provide a result but are not in everyday use, at least for me.
Yeah, so with FME, I guess specifically, or with Child Abduction Response Team. I guess with FME, it took me probably to really feel comfortable with FME. It took me a couple of years, I guess, to really feel it's pretty easy to get into it. I mean, there's a lot of online resources and there's a lot of things that you can learn online. But to really feel comfortable using it every day, it definitely took a little bit of time because it is a little bit of a different mindset, kind of like with anything. With the Child Abduction Response Team stuff, Adam Tim Dorn, who had my position before me, he set up a lot of the Arcgis online stuff and a lot of that, and a lot of the terminology as far as the cart stuff goes. And then I just kind of, did my part of it. So.
Okay, great. Thank you. Got another question. Kim, did you want to do your own question? Our co-moderator had a question.
Nice.
I've been dabbling in FME for like 20 years, and I still consider myself very much a dabbler. But I was really happy to take it on again when Dispatch started buying it for us. So my question to you was, is that who pays for the, does law enforcement pay for your license for desktop and server, or does that come out of your GIS budget?
No, that comes out of the GIS budget.
Okay.
Yeah. I mean, yeah, desktop was relatively inexpensive. I mean, I think they do offer some discounts for, small and local governments and things like that. I want to say it was like $2,000 maybe or something for the desktop, I think. Server was definitely a lot, after I was kind of able to showcase a little bit more what I could do with desktop. We then went to FME Cloud, which is definitely the cheaper option if you want to get into the server side of things. And then after we did FME Cloud for a little bit, then we went full in on FME server on-prem. So. And that was definitely a little bit more of a financial commitment, but all of that goes out of the GIS. So yeah, no, law enforcement didn't pay for any of that. So I mean, and this is just one facet of how I use FME and FME server here. I've pretty much transferred not all, but a lot of the nightly data processing within the city and stuff to through all FME. So it's not just used for that, but it's used for many other things. So.
Okay, do we have any other questions for Matt? Don't see anything else in the chat. Thank you so much for giving us that informative presentation.
Thank you.
Yeah, thanks for being here.
Yeah, thank you.